Good morning, students. Today we will discuss about Engineering Mathematics 3. The subject code is CIT Common 301 and in that lecture number 2. Okay. In this lecture number 2, today I want to cover the topics are standard integrals. Okay. In the previous class, what we have discussed, what is meant by integration. Now, based on that definition, we are going to define some standard integrals. In that, algebraic standard forms, exponential, logarithmic, trigonometric, inverse trigonometric, hyperbolic, trigonometric, and some properties which is required for solving the integration problems. We are going to discussing these two things today in this session. Now, first we'll go for standard integrals. Okay, standard integrals. In this standard integrals, we know already the definition of the integration. What is the definition of the integration? Again, we will go for one example. Differentiation. The reverse process of the differentiation is known as a integration. So let us take one example for the differentiation. What is the differentiation of sin x? What is the differentiation of sin x is cos x. Okay. The differentiation of sin x is cos x. Now, according to the integrations, what is the mean of integration? It is a simply reverse process. So that means by taking this cos x, you will get the sin x. But how to represent in a symbolic manner? That is integration cos x into dx is equal to sin x plus c. Why we are adding the plus c? Because these integrations comes to the category of indefinite integrations. So integration of cos x into dx becomes sin x plus c. So this is called standard form. Like that we can write number of standard forms. I will attach the list of the standard integrals. More than 25 integral standard forms are there. In that, I wanted to write here some of them which are very important. Okay. Now, one. We'll start with some of the algebraic. We know that what is the integration of 1 into dx? Simply x plus c. Second one, integration of a to the power of x into dx. Here is a to the power of x by log a plus c. Okay. Then we'll go for exponential. So here the exponential function of the integration is again same, because in the differentiation also e power x differentiation is e power x. Then the reverse process means e power x integration again e power x plus c. So then we'll go for logarithmic. So here the logarithmic log x differentiation is 1 by x. So similarly 1 by x integration becomes log x plus c. Very good. Then trigonometric functions. In that we I am going to write some of the trigonometric functions here. That is, we are already discussed differentiation of sin x is cos x. That means cos x integration is sin x. Similarly, integration of sin x is minus cos x. Now, similarly we can write inverse trigonometric functions and hyperbolic trigonometric functions. Now, I will attach that list into the link below in this session. Now, again coming to the properties of integration. So here are some properties of integrations. So basically, why these standard integrals and properties are required? To solve the integral, to obtain the integral values of the given integrand, we need these kind of standard integrals and some of the properties. Here the basic two properties are there. One is distributive property, another one is coefficient property. Coming to the first one, distributive property. If the function, that means integrand is consistent two or more function. It consists of two or more function. Either it is a plus or minus. Then we can easily split into the integration of f of x into dx plus or minus integration g of x into dx. This is the property number one. Then coming to the second one and the last in this property, integration any constant with the function. That means integrand is consistent with any constant. We can simply write out of the operation. What is the operation here? Here the integration is the operation. So we can write out of it. This is two properties are very important. Let us check one example with evaluate integration x square plus cos x plus e to the power of x minus 1 into dx. So how to evaluate this? This is called integrand. Yes or no? This is called what? Integrand. Now this is called the symbol of the integration. What we wanted to do? Evaluate. That means we have to integrate this integrand. For what? To get the integral. To get integral. So how to find that one? So here we simply keep in our mind one standard integrals and another one is properties. By going to the properties, here we can easily understand this integrand is consistent two or more functions. So we just simply split it. Now what is the x square integration? Here the x square integration, okay, I will write you x to the power of n into dx is equal to x to the power of n plus 1 by n plus 1 plus c. Once again I am telling you that after this session you please go through the attachment which is given in the link. Okay, so in that standard integrals will get. So x square is then x cube by 3 by this property plus standard integral. Then cos x integration. What is the cos x integration? We already know. By the standard integrals we can write directly sin x plus e to the power of x. What is the e to the power of x integration? E to the power of x minus 1. 1 integration is x. So whole integral, just now I am adding only one c, because by adding all the c's also it becomes a constant, that is arbitrary constant. Okay, so this is called integral. So now again you see this, here the given integrand, I am integrated, I got integral. That means the integration formula, the simple basic formula, that is for obtaining the integral by using the integrand. Okay, so that process is known as a integration. Thank you, students.